Assalamualaikum and hi everyone. For question 2, our task is to design a saw link mechanism for a lumber mill where the saw blade must stay horizontal and complete a full back and forth motion in 10 seconds. We are given an electric motor with shaft rotation of 50 radian per second and the motor position is flexible. On this sheet, I sketched 4 possible mechanisms, labeled design 1 to design 4, and after comparing them, we selected design 4 as our final choice. So for the design one, use a rotating wheel and a connecting rod directly pulling the saw carriage. It can create a reciprocating motion, but it may introduce unwanted angular changes or extra vibration if the guidance is not perfect. Design 2 use a 4-bar type linkage to control the motion more smoothly, but it becomes more complex and needs careful dimensioning to keep the saw blade perfectly horizontal. And the design 3 use a simple linkage arrangement, but the transmission part is longer and may reduce stiffness and accuracy. Now I will explain design 4. I will choose design. In design 4, the system is divided into two main parts. First, the motor to motion conversion. The motor drives a crank disc at the side. A pin on the crank connects to a connecting rod. As the crank rotates, it converts the rotation motion of the motor into a back and forth linear motion along the rod direction. Second, the saw carriage and blade guidance. The connecting rod is attached to a triangular linkage at the saw end, which is connected to the saw carriage. The saw blade is mounted on a guide frame so that as the linkage push and pulls, the blades move horizontal only, maintaining the required horizontal orientation during the entire stroke. During one full revolution of the crank from 10 degrees to 180 degrees, the connecting rod pushed the linkage, moving the saw forward through the cutting stroke. From 180 to 360 degree, the rod pulls back, returning the saw backward for the return stroke. So the saw completes one full reciprocating cycle per crank revolution, and we can adjust link lengths or use speed reduction so the mechanism achieve the required 10-second full cycle. So to summarize, design 4 is selected because it provides a clear conversion from motor rotation to reciprocating motion, better control to keep the blade horizontal, and a structure that is practical to model and analyze using kinematic software, including plotting velocity and acceleration versus position as required. Thank you.
Today I want to present about theoretical calculation for our project, our dynamic project. So we go to our first model that we choose. So we get a one rod here, and the angle for AB is 25 degree and for BC is 30 degree. The angular velocity is 50 rad per second. So we go for the first question, which is VB over VA plus angular velocity VA times RBA. So VA is 0 because A is a fix, and we just put the omega VA here, and then we calculate the RBA for AB rod, and we just doing a dot product, and then we got negative 2.10I and negative 4.55 J for the VB. After that, we go to the VC equal to VB plus omega CB times RCB. For this equation, we got two unknowns, which is VC and omega CB. And the same as before, we just do a cross product for omega CB. And we separate for I component and J component, which is I component we got velocity 4.727, and for J component we got omega CB, which is negative 2.627 radian per second. For acceleration, we got 10 seconds, which is time that given the question. And we got a formula for angular acceleration, which is alpha equal to omega over t, which is times. So 50 radian per second over 10 seconds, which is we got 5 radian per second square. So for acceleration, the equation is AP equal to AA plus alpha BA times RBA minus omega BA RBA. Calculation, we just put the value and then alpha, oh sorry, acceleration for A also 0 because A is a fixed. And then for alpha BA times RBA is a cross product, and then omega BA RBA is a dot product. So just times this, and then for this one we do a dot product. So we got for alpha for acceleration B, sorry, 287.24 I and minus 105.455 J. And we go to the AC, acceleration C, same as the question before. AC equal to AB plus alpha CB times RCB minus omega CB square RCB. And we just put the value. So the cross product is here and the this one is dot product. So and the second last solution is we got here, and then we just sum up the I component and J component together, exclude this, and then we got this, and then we go separate for J component and I component. For J component, I got alpha CB, which is 56.90 radian per second square, and I component, I got acceleration 182.25 in second square. So that's all for our calculation, for theoretical calculation for our project. Thank you.
Now, let's focus in SolidWorks. By using this software, we are managed to assemble all the components in our project. So let's focus to one by one point. First, motor. Despite of the model show the motor and crank system, which is the main power source for the mechanism. The motor provides rotary motion, and around this attached to the shaft and the crank. A pin of the crank is connected to the vertical link connecting rods. When the motor rotates, the crank pin moves into circular and force the connecting rod to move back and forth. This back and forth movement is being transferred through the linkage to drive the saw blade in the reciprocating horizontal motion. In short, the motor supplies the rotation, and the crank link connection convert the rotation into the motion needed for cutting. Next, we got the connecting rod. Despite it's the connecting rod of the mechanism, its main job is to transfer motion and force from the motor side to the saw side. One end of the rod is joined to the crank link near the motor, and the other end is joined to the saw blade mechanism by using the pin joints. Where the motor rotates, the crank makes one end the rod move in the circular path, and the rod then convert and carry that motion forward, causing the saw assembly to move back and forth in the straight lines. In the simple terms, this rod works like a bridge that delivers motor movement to the saw blade system. And finally, we got a saw blade assembly. Despite of the saw blade assembly perform cutting in the mechanism, it is designed as a rigid frame with a two blade edge and is connected to the linkage on top through a pin joint. The linkage push and pull the saw assembly so it can move back and forth horizontally across the wood.
Assalamualaikum warahmatullahi wabarakatuh. Ini saya nak tentangkan design solid mechanism di dalam GIM software. Ini adalah soalan di mana saw yang digerakkan oleh power source sebesar 50 rad bergerak back and forth dalam masa 10 second Ini adalah bentuk sketch dalam GIM untuk design saw tadi. Ini adalah motion yang untuk sketch tadi yang dalam GM software. Okey, dekat sini adalah velocity di point A, dan di sini pula adalah velocity dekat point B. Ini pula velocity dekat point C. Bacaan yang JIM dapat, dan ini pula bacaan velocity di point D. Dan seterusnya acceleration, bacaan acceleration di point C, bacaan acceleration di point D, dan bacaan untuk angular acceleration dekat segmen A dan B. Dan terakhir sekali ialah angular bacaan untuk angular velocity dekat segmen BC. Terima kasih, itu saja design yang saya sketch untuk GIM software.